A manufacturer of cheese-filled ravioli supplies a pizza restaurant chain based on data collected from its automatic filling process. The amount of cheese inserted into the ravioli is normally distributed to make sure that the automatic filling process is on target. Quality control inspectors take a sample of 25 ravioli and measure the weight of cheese filling. They find a sample mean weight of 15 grams with a standard deviation of 1.5 grams. What is the margin of error at 90% confident? All right, so this question is normally distributed. So we're going to apply the normal distribution to this problem. And let's take a look at the picture. So we know that we have 90% confident, right? So we have 90% confident, that is the middle area. And therefore, your alpha level would be 10% or 0.1. So we have 5% over here or 0.05. And also the other 5% is here on the left tail. So we have a total of 100%. Now, we know that the center will be the sample mean, right? And then this is the upper bound for the confidence interval, and this is the lower bound. Now, to get to the lower bound or the upper bound, we will add or subtract the margin of error. If you go to the upper bound, you're gonna add the margin of error E. If you go to the left, you're gonna subtract that margin of error E. All right, what is that margin of error? That is the question for this problem. So we want to look for what is the E. We know that we have a sample size of 25, so that is the N. And since this sample size is less than 30 and we are told that it is normally distributed, so we are okay to move on and apply the formula to this question because it is assumes that the population is normally distributed. Now, the sample mean in this case is 15 grams or the X bar, right? This is the sample mean, X bar is 15 grams. And the sample standard deviation is the small s, is also 1.5 grams. Now, in this question, we know nothing about the sigma or the population standard deviation. Therefore, we are using the t statistic, right? The t distribution instead of the z distribution. If we know the population standard deviation sigma, we're gonna use the z distribution. And if we don't know the population standard deviation, we will use the t or student t distribution. Now, according to the formula, we know that the sample mean, right, plus or minus the E will get you to the lower or the upper bounds. And the margin of error, in fact, it is simply just the t, the critical value, or t alpha half. Alpha half is 0.5, right? Alpha half, 0.055%. And we have the, and we multiply by the sample standard deviation over the square root of n, or the sample size. So this thing right here is the margin of error, which is the one that we are looking right here. So first thing is I have to find what is my critical value, right? Critical value. Now, this is a t distribution, t alpha half. To find the critical value, we will use the inverse t function. And remember, whatever you put in here, right, must be the left side. So we have 0. Let's look at this point right here. 0.05 is the right area. And the input for the inverse t must be the left side area. So we have 90% and also 5%. So that is 95. 95. And then the left side area and the degree of freedom and subtract 1, in this case 25 minus 1. So this is the degree of freedom df. And let's use the TI-84 to do this calculation. Okay, so we have second distribution. We're gonna get to invert t. The area would be 95%. On the left side, the degree of freedom is 24 because we take 25 subtract 1, and that will give me 1.71088. Okay, and then we take this number, right? We're gonna multiply the small s. So we multiply with the 1.5, and then we will divide everything by the square root of the sample size, which is 25. And that is the margin of error, 0.5133 rams. So E 0.5133 rams.